Hey everyone, I'm going to talk a little bit about GraphQL and why distributed SQL and the innovation in the database industry around distributed SQL is very important to us. So I hope to share with you the perspective of a consumer of these databases, and specifically share with you some kind of movements and insights that are happening in the web application development world that might be interesting to you. So a little bit of an introduction. I'm the founder of Hasura. We started Hasura just about 2 years ago. We open sourced Hasura just exactly about a year ago, and developer adoption has been great. We do real-time GraphQL on Postgres, among other things. And during that short amount of time, we've sneaked our way into several Fortune 500, several high-growing, like fast-growing startups. And we've seen great validation of the value that we're providing, which is essentially making data access easy, secure, and stateless. I'm super passionate personally about making it easy to build things. I taught a course a long time ago that became the largest MOOC in India with like 250,000 students a year. And making it easy to be able to access data, I think, is one of the big problems for developers today, right? So what do developers today want to do, right? So you see a few landscape slides that I've put up. Developers today want pretty much the same thing that they've always wanted, which is to write code and have it work. And specifically today, they want automated ops so that they have as much ownership as possible of their own code, right? And this is kind of, on the business logic front, you're seeing people move towards containers and specifically serverless. And on the application logic side, you're seeing, I don't know how many of you have come across this term, but you're seeing stuff like Jamstack, which is this idea of having rich front-end client-side applications. So on the top, you see a slide on the functions as a service landscape, which is kind of growing super fast. And on the bottom, you see the quote-unquote Jamstack landscape, which is the front-end ecosystem that's also growing very, very fast. So application developers here, the kind of core problem that they have, and if you can see the bottom here of the slide, let me just bring my pointer up, is this little GraphQL piece here, right? Which is that these application developers, they want to access data, and they want to access data in a format that they like. And this format has emerged, one of the contenders for this, for making this data access easy, has been GraphQL. GraphQL was open sourced as a spec, as an API spec just a few years ago by Facebook. And it's kind of caught on like wildfire amongst developers and application developers. So to give you a little bit of context, of what GraphQL looks like as a data API, GraphQL is an API designed for application developers. So it's JSON first. The idea is it's kind of like a SQL, but for your API, right? So it gives you an intuitive graph model over JSON. The query that you see on the right here is a GraphQL query. You can see that it's kind of like the shape of your JSON that you want, right? So from that backend system, from your API, it's the shape of the data that you want to query for, and that's kind of what the query language looks like. So I'm fetching customers, maybe their names and emails, and maybe the saved cards for this customer so that I can render this on an e-commerce page or something. Because GraphQL is an API, it's a stateless HTTP boundary, so that means that developers don't have to care about connection pools, they don't have to care about how they're connecting to an underlying data system. And also because it's an API, it's a secure boundary, right? The big reason behind why GraphQL became very, very popular or has become very popular is because the API exploration experience, the IDE, the client-side tooling is great. It's a lot like the SQL tooling, which is great in the ecosystem, but that brought for developers who are consuming APIs and building applications, right? So imagine that you're building an app, and you're getting autocomplete for the GraphQL query that you're writing, similar to ID that you might use for writing in SQL, and then getting autocomplete for your SQL, right? Which is amazing that it's happening only so late, but which is still mind-blowing for application developers. One of the other cool things about GraphQL that fits into the event-driven transition that we're also seeing in the world today is to do with subscriptions. And so GraphQL as an API spec has first-class support for a real-time construct called GraphQL subscriptions, which allows you to capture changes in data, events in the data system on the back, and then use them on the front end fairly easily, right? So that's kind of what makes GraphQL easy. Just to quickly show you what that looks like, let me bring up a demo quickly. I'm a little confused about the new escape key on this touch bar. All right. So let's see here. All right, so I've loaded up a simple kind of database here, which is a Chinook database, just a simple relational schema. I've put this into Postgres, Yugabyte. And what you can see here is that you have like albums, you have artists, just a simple schema, right? What GraphQL gives you, and when I throw Hasura on top of GraphQL, let me zoom this up a little bit, is that you get an API interface. And so that's the API endpoint that you query as a developer. And you get this explorer here. And this is kind of all auto-generated, right? So what I can do is I can say, I have albums. I want to fetch albums, their IDs and their titles. And I want to fetch the artist of this album and the ID and the name of this artist as well, right? This is running on Heroku, so it might take a little bit of time to start, but fingers crossed. There we go. And so you see me fetching like 300 elements from here. And the shape of the data that I get is the query that I ran, right? And you can, of course, make this more complicated. So you can say I want those albums where the artist's name, starts with whatever, starts with, let's say, an A, hopefully, right? And so that's kind of the GraphQL query that I'm running. Now, this is super nice for developers because standard HTTP query, very powerful because I'm running this on Postgres or something that speaks Postgres. And the nice thing is that what I can do is I can actually see the underlying SQL query here, right? And I can see what the SQL plan is, and I can figure out, hey, you know what, this query is slowing down. Maybe I need to add a few indexes or do whatever. So this is just a quick view of what GraphQL looks like, just to help you get a sense. The cool thing with GraphQL, though, is that it's kind of data source agnostic. So it helps you kind of join across data sources. So for example, I have another example here where I'm joining data that is inside my database with data that is coming in from Stripe to fetch the saved cards, I guess. And so I'm making this query here. And this data is coming in from the customer table that we have here internally, which is the customer table, and data that is coming in through a relationship to the Stripe API. So I'm joining across kind of like a view of the data that I have in the database and stuff that I have inside, or data that is coming in from a SaaS API. So that's kind of what GraphQL does, and this is why GraphQL is super exciting to application developers. Now, to put this in context of why, or briefly give you a sense of how this works. This works because what Hasura does is, and what we do is, it's basically a metadata engine, right? So inside that metadata engine, you're creating mappings for your data models. You're storing transformations of your data models with views or computed columns. You're setting up relationships between your data models or data models and external services. And then, of course, this metadata helps you handle API and model deprecation as models change. And most importantly, set up authorization and permission rules. This is kind of like what we've done is rebuild Postgres RLS inside the application layer, a fairly advanced version of RLS. We built this technology just before RLS landed in Postgres. There was a RLS bug that came up in Postgres that came up in our system as well. And so that's kind of what Hasura does. And if you have your own GraphQL API server, you would do similar things. The reason why distributed SQL is super important in this context is because GraphQL queries, just like SQL queries, fetch data dynamically, right? And that means that you need to optimize that data fetching from the underlying data source. Our approach is to actually behave like a just-in-time compiler, which kind of transpiles GraphQL queries, uses the metadata, and then converts that to a SQL query. This is great, but this stops working very soon when you realize that your database does not scale, right? Having SQL on the back is very easy, and there's a nice mental model that you can create around how to optimize your data fetching. But that doesn't work if the backend database itself does not scale. So for a user of Postgres, like Hasura or like anybody else building this kind of a system, it's very important to have a system that can scale out, and that's something that everybody as an application developer has really been waiting for. And that's kind of one of the things that's very exciting about systems starting to speak Postgres, systems starting to speak SQL, and the demos that I'm showing you or some of the stuff that we've done has been with Yugabyte as well. And that works absolutely great. It's important to be able to reuse the same tooling that you have around SQL, stuff like explain, so that you can debug faster, you can make things work faster. This also leads to a fairly good use case that is also emerging, something that I've been seeing fairly commonly with a bunch of startups and some of our users. It's kind of like this data platform use case, especially for real-time IoT, ML, AI kind of use cases where you have lots of data that is being kind of created, processed, and then being materialized inside something that can just handle it, right? Something that can just store terabytes and terabytes of data, and then you can have a rich query interface on top of it that kind of gives you query responses fairly fast, quote unquote real time. And this is a massive boost to agility because the GraphQL spec gives application developers a stateless and a secure boundary, and having everything inside a nice Postgres speaking database that scales out is super useful. So the other quick thing that I want to talk about is how rights and workflows are evolving for developers. Kind of touches upon the event stuff that we were talking about in the previous talk. So this is kind of what a typical e-commerce workflow looks like if people are building those kinds of applications today, right? So you have a GraphQL API in the front that maybe applications are speaking to that. And then everything is kind of event-driven on the back, right? So you have events going into microservices or serverless functions, which are speaking synchronously to their own databases. And everything is kind of event-driven, and then responses come back as events as well, right? So great on paper, but it's super, a few things become very complicated for application developers. The first bit, which is obvious, is the synchronous and transactional interaction that one particular microservice might have with the database itself. That portion needs to scale. One of the folks, one of the architects on our team is the person that built out the event-driven system at Flipkart, which is India's Amazon, which runs at massive scale. And this was the reason why they had to, this particular problem was the reason they had to undergo a massive amount of refactor. They spent about 1.5 years with a huge, expensive engineering team, basically removing their relational database and using kind of this hybrid workflow to manage transactions with part of their data in Cassandra, part of their data in MySQL to manage transactions, having some edge cases which they would have to manually recover from, and was challenging. So having that piece fixed is very important, and having transactions work at that scale is very important. But the other piece also for kind of more modern applications is that as events come in, the front-end applications and the end-user applications are also going to need to become event-driven, which is why GraphQL is so popular. But that kind of also needs to fit in to the eventing stuff that's happening on the back, right? One of the two important things for developers here is having a nice way to kind of capture CDC or notifications on data changes so that you can kind of stream state back to the client. And also consistency so that when you're reading from the same, when you get an event that comes back from a microservice, you want to be able to make sure that when you're enriching that event and reading more data related to that event, you're getting a consistent read, right? You don't want to read for data related to that event and then see that the data is not there. And that's another piece that's super important. And it's been, in our tests, it's been nice to see that this works pretty well with Yugabyte as well. So I have a simple example and a demo that we can kind of try out, which would be fun to try out, where the stack is basically this. I have a GraphQL API, which is real time. I have a database that speaks Postgres with a Stripe kind of system that's kind of stitched in for the data graph. And all of the business logic is in serverless functions. And this is nice because as a developer, the only thing I care about is data modeling. I care about my business logic, and I care about my app logic, which is the front-end application itself. And for free, I get scalability and fault tolerance, right? Free is in quotes. Apparent, right? And this works really well. And this is a sample application that I usually use for demos. So if you have your phones, you can whip out your phones and scan this QR code. Just going to keep it up for a sec. All right. I'm hoping some of you have it. Cool. So this is a simple application. What I'm going to do is say put in Tango 789, right? And so what I'm doing now is I'm going to place an order. So I'm reading in applications. I'm reading in data that I have donut, haggis, mango. I'm going to get haggis and mango. That's what I feel like. And so now I'm placing an order, right? And now you'll notice that everything is event-driven. So this entire UI now is event-driven. You're seeing the stuff on the bottom that's kind of coming in from a stitched-in sample Stripe saved card, and you're seeing that data that is coming in from Postgres itself, and you're seeing everything happen kind of in real time, right? So let me whip this analytics piece out here. Some of you are placing orders, which you can see happen here on the left. And now as I make that payment, which is the next step in that event transaction, that goes, hits, runs a serverless function that does something, goes and updates the database, change notification comes in, and then that kind of refreshes the app, and that refreshes that graph that I have there as well. And it's a significant amount of engineering to get this to work at a fair amount of scale as well. We've got this working on about 1 million active GraphQL subscriptions, which has been kind of cool, which works with Postgres speaking systems. We're going to hook this up to Yugabyte CDC as well, and do a few benchmarks there as well. So that's kind of a nice that's kind of nice for developers to be able to build systems like this, modern systems like this, without putting in too much effort. And I'm sure this is not going to be new to you folks, but let me see if I can quickly get this running. All right. But for application developers, one of the big benefits of having event-driven systems, and this is a recorded demo of me testing this out, placing thousands of orders at a time. So I go in and I place 1,000 orders, and you see that like 1,000 orders just got placed instantly. Now there's a lot of business logic that's running, that's doing stuff, talking to the database, doing some synchronous stuff, doing some asynchronous stuff. And so you're seeing that order validation logic, which is the second step in that workflow, kind of kick in, bunch of orders getting validated and getting blocked on payments, right? And then I go to the UI, I make like 1,000 payments in one shot, and you'll see that kind of graph pop up. And now to kind of simulate a failure, I'm going to disconnect like the network between the eventing system and the serverless function system, right? And so now there's a transient failure. And you'll see that some of them get processed, and then it starts kind of stopping out, right? For those orders that reach that stage, the next business logic step kicked in, but it's kind of paused there. And now everybody's panicking, and they're trying to figure out what went wrong. And so somebody found that the LAN cable is unplugged, and it's like, put in the LAN cable back. I'm going to click on a AWS button to get the LAN cable back. Right, so I go to AWS and I say, remove the throttling and save it. So I hit save there on the top. And then everything should kind of just pick up from where it left off, right? So as an application developer, this is the experience that I want, right? I want things to just work. I just want to write my code. I don't want to have to care about transient failures. I don't want to have to care about scale. I already have compute that is elastic. I want everything else to kind of just work as well. And so that's kind of the experience that we're hoping to provide along with database solutions that are evolving. We're going to start adding more and more adapters for distributed SQL speaking databases. With Yugabyte, the experience has been great because it speaks Postgres. More people should speak Postgres. Spanner. But what? Where did that come from? All right, that's me on Twitter. Please hit me up if you'd like to chat about this a little more. And do check us out on GitHub as well at Hasura/GraphQL Engine. Thank you for having me.